Hi, morning. Let us continue the previous session where we learned in the previous session about the spontaneous absorption, spontaneous emission and stimulated emission. Let us the production of laser and what is the basic nature required for the production of laser, that is stimulated emission. When you get a stimulated emission, when you get a spontaneous emission, the condition of getting spontaneous emission or stimulated emission can be explained with the help of Einstein coefficients. Let us study about Einstein coefficients and the importance of Einstein coefficients with deriving them to satisfy the condition of stimulated emission process. For this, we have to take two energy levels E1 and E2, which have the number of atoms present in the E1 as N1 and E2 as N2. Let N be the number of photon energy that is applied to the material, where H nu is equal to E2 minus E1 photon energy. Then the energy density interacting photon is given by rho nu is equal to N into H nu. So this is the interaction energy with the substance by means of absorption or by means of emission. So the energy density interacting photons rho nu is given by rho nu is equal to NH nu. When this photon energy interacts with the atom, both upward, that is called absorption, and downward, where it is called emission. The downward process emission and the upward process absorption both are equal because of the equilibrium state of the material. And let us know about first the stimulated absorption, upward transition. Stimulated absorption is the rate depend upon the number of atoms available in the energy state E1, that is N1, as well as the interacting radiation. The stimulated absorption rate is directly proportional to N1, and that is directly proportional to also rho nu. Therefore, the stimulated absorption is given by directly proportional to N1 into rho nu, which is equal to N1 rho nu, a constant, proportional constant is taken B12. Here B12 is nothing but absorption of energy by taking from first state to second state. Electron is jumping from state 1 to state 2. This is the representation of Einstein coefficient, absorption Einstein coefficient B12, and where this absorption of energy is taking place by the material, there the stimulated absorption is get satisfied. And once the condition is known to us, when the electron is present in the excited state, it will not stay for a long time on the excited state. After that, it has to come down by means of two downward transitions. One is spontaneous emission, the other one is stimulated emission. Let us take the energy density by the spontaneous emission. The spontaneous emission rate is depend upon the number of atoms present in the excited state E2. That is why spontaneous emission rate is directly proportional to N2. Therefore, this spontaneous emission energy is given by N2 into A21, where A21 is a emission coefficient, where the emission coefficient is taking from 2 to 1. Where proportional constant A21 is the Einstein coefficient spontaneous emission. Einstein coefficient of spontaneous emission A21. Similarly, the other process emission is stimulated emission. Stimulated emission rate is depend upon the number of atoms present in the excited state E2 and also the energy, radiating energy supplied to the specimen. And this from this we can take that from the stimulated emission rate, stimulated is directly proportional to N2 and rho nu. Therefore, the stimulated emission energy is equal to N2 rho nu into B21. As you know that the proportional constant B21 is the Einstein coefficient of stimulated emission, and where it is taking place from 2 to 1 state. and according to the equilibrium system of the material, the absorption energy is always equal to emission energy. Here the emission process is done by means of two. One is spontaneous emission, other one is stimulated emission, the sum of emissions. Therefore, the absorption energy rho nu B12 into N1, here N1 is equal to N2 rho nu B21 plus N2 A21. And now taking the rho nu term into this side, rho nu is equal to N2 A2 by N1 B2 minus N1 B21. And now rho nu is equal to, this is the value where we are getting. Next, the population of the electrons present in any energy state is given by the Boltzmann distribution law. The Boltzmann distribution law is I is equal to N0 into exponential minus EI by KT. Similarly, we can write N1 by N2 is equal to exponential H nu by KT, where H nu means E2 minus A1. And there rho nu is equal to A21 by B21, taking common, divided by B12 by B21 into exponential H nu exponential H nu by KT minus 1. And but the transition emission B12 and B21, both the energies are constant, they are taken as equal, and substituting the equal nature, we have rho nu is equal to A21 by B21 exponential H nu by KT minus 1. From Planck's radiation law, we can write that energy density rho nu is also given by 8 by H nu q by Cq into 1 by exponential H nu by KT minus 1. This is the energy density according to the Planck radiation. Comparing the equation 9 and the equation 8, we get A21 by B21 is equal to 8 by H nu q by Cq, where A21 is nothing but spontaneous emission, B21 is nothing but stimulated emission. The A21 by B21 is equal to, means spontaneous emission by stimulated emission, is equal to 8 pi H nu q by Cq. Here 8 pi H are the constant, C also constant velocity of line, and nu is the variable. Depend upon the new value, the value of 8 pi H nu q by Cq is changes as follows. If 8 pi H nu q by Cq is greater than 1, then spontaneous emission by stimulated emission is greater than 1. Taking stimulated emission to that side, spontaneous emission is greater than stimulated emission, so that what occur? Spontaneous emission occur. If 8 pi H nu q by Cq is less than 1, then stimulated emission is greater than spontaneous emission, hence the stimulated emission process is occur. So you want to stimulated emission process, the condition to be satisfied is 8 pi H nu q by Cq should be less than 1. This is the satisfied condition for the getting of a stimulated emission process. This is the basic condition of Einstein coefficient. So to explain about stimulated emission process for laser action, A21 by B21 is equal to 8 pi H nu q by Cq. Thank you.